Everything we know about life, every creature, every ecosystem, every civilization that has ever existed, fits on a single pale blue dot. One world in an ocean of 400 billion stars. The question is not whether other worlds exist. We have found more than 6,000 of them. The question is, which ones? In March 2026, a team of astronomers at Cornell University did something that had never been done before. They took every exoplanet ever discovered, more than 6,000 worlds, and filtered them, planet by planet, star by star, until they had a list. 45 worlds, rocky, in the habitable zone, with the right amount of heat from their stars. 45 planets that could, right now, have life on them. Welcome back to David Planetborough. Last time, something ancient came to us. 3I/Atlas, a comet from another star, carrying the same chemistry as our own solar system. It told us the universe makes the same ingredients everywhere. Today we ask, where are the worlds those ingredients built? And could any of them be alive? If you're new here, this is Quest for Alien Life. Subscribe so you don't miss the next discovery. For 30 years, finding exoplanets felt like a gold rush. Every new telescope, Kepler, TESS, the ground-based giants, added hundreds of worlds to the catalogue. By 2026, we had confirmed more than 6,100 planets orbiting other stars. An extraordinary achievement. But the list had become a problem. It was vast, unstructured, a sprawl of gas giants, scorched rocks, frozen worlds, and strange systems orbiting stars nothing like our Sun. More than 6,000 planets, and no map for where to look for life. What was missing was not planets. What was missing was a method. A way to take everything we had found and ask, which of these could actually support life? Not theoretically, not in science fiction, but with liquid water, stable temperatures, and the kind of chemistry we understand. Which worlds deserve our telescopes? Which ones do we point JWST at next? That is exactly what the Cornell team set out to answer. The paper was published on March 19, 2026, in the monthly notices of the Royal Astronomical Society. Its lead author was Abigail Bowl, an undergraduate at Cornell. The team also included Professor Lisa Kaltenegger, director of Cornell's Carl Sagan Institute, one of the world's foremost experts on planetary habitability. They used two of the most comprehensive astronomical databases ever assembled, the NASA Exoplanet Archive and the European Space Agency's Gaia Mission Star Catalogue, the most precise map of our galaxy ever made. The foundation of their search was a concept called the habitable zone, sometimes called the Goldilocks zone. It is the band of orbits around a star where temperatures are neither too hot nor too cold for liquid water to exist on a planet's surface. Not too close to the star, where water boils away. Not too far, where it freezes solid. The zone where conditions are, in the oldest of astronomical clichés, just right. Our Earth sits comfortably inside our Sun's habitable zone. These 45 worlds sit inside theirs. But the habitable zone alone is not enough. A gas giant, a planet like Jupiter with no solid surface, can orbit in the habitable zone and still be entirely hostile to life as we know it. The Cornell team filtered for rocky planets specifically, worlds with solid surfaces where liquid water could pool, where chemistry could concentrate, where life might find a foothold. That single filter eliminated the vast majority of candidates. First filter, is it rocky? Thousands eliminated. Second filter, is it in the habitable zone? Thousands more gone. Third filter, is the star stable enough to give the planet time for life to develop. More gone. Fourth filter, does the orbital data from Gaia confirm the earlier measurements? The funnel narrowed, and at the end, 45 worlds remained, from more than 6,000 to 45. Each of those 45 worlds is a chapter in the larger story we're telling on this channel, Quest for Alien Life. The full series is in the description. Keep watching. The study actually produced two lists. The larger, 45 worlds, sits within what astronomers call the empirical habitable zone, defined by observing Earth and Venus as benchmarks. The smaller list, 24 worlds, sits within a tighter, more conservative zone that assumes a planet can tolerate less stellar heating. If life requires stricter conditions, those 24 worlds are the shortlist within the shortlist, the most promising of the most promising. Let's meet some of them, starting with the one that is closest. Proxima Centauri b orbits the nearest star to our Sun, Proxima Centauri, just 4.2 light-years away. If any spacecraft we have ever built could reach it, it would take approximately 73,000 years at current speeds. And yet, it is our nearest confirmed rocky world in a habitable zone.
It is likely tidally locked, one face permanently baking in the red light of its star, the other in eternal frozen darkness. The narrow twilight band between them might be where conditions are tolerable. It made the Cornell list. It is on the shortlist. Then there is TRAPPIST-1, a single ultra-cool red dwarf star, just 39 light-years away, hosting 7 rocky planets, all of them roughly Earth-sized. 4 of those 7 sit inside the habitable zone. 4 worlds around 1 star, each potentially capable of supporting liquid water. The Cornell study included TRAPPIST-1F on its list. JWST has already begun studying the inner planets of this system, and while the results for the innermost worlds are cautious, the further planets, with their greater distance from the star, are still accumulating data. TRAPPIST-1 is, by any measure, the most extraordinary nearby planetary system ever found. But if there is one world on this list that has every astronomer's attention right now, it is LHS 1140b. Located 49 light-years away, this super-Earth orbits quietly in the habitable zone of a red dwarf star so calm and inactive that it barely disturbs the planet's atmosphere. JWST has already looked at it. What it found was extraordinary. Hints of a nitrogen-rich atmosphere, the same dominant gas as Earth's air. Some models suggest LHS 1140b could be an ice world, with a frozen surface concealing a liquid ocean beneath. Others suggest a snowball planet, with one liquid eye staring at its star. Either way, it may be the most promising habitable world we can actually study with the technology we have right now. TOI 715b was discovered by the TESS Space Telescope and confirmed in 2024. It sits 137 light-years away, orbiting a red dwarf star so dim that even a 19-day year puts it squarely in the habitable zone. It is 1.5 times the size of Earth. Its star may also host a second planet, possibly Earth-sized, making this one of the most intriguing nearby systems for future observation. It sits on the Cornell list. JWST has not yet fully turned its attention here. When it does, the results could be remarkable. And then there is Kepler 186f, a landmark. The first Earth-sized planet ever confirmed in the habitable zone of another star, discovered in 2014. It orbits at the outer edge of its habitable zone, meaning it probably receives only a fraction of the warmth Earth gets. It is cooler, darker, a world where a summer's day might feel like Earth's deep winter. But it is the right size. It is in the right place.
and it has been on every shortlist since the day it was found. If this is the kind of science that makes you stop and think, the like button sends it to more people who should see it. What makes this moment different from every other moment in the history of this search is a single instrument. The James Webb Space Telescope is now systematically working through the most promising of these worlds, reading their atmospheres with infrared light, looking for the chemical signatures that life tends to produce. Water vapor, carbon dioxide, methane, and potentially biosignatures, molecules that should not exist in the quantities detected unless something biological is producing them. The Cornell list is, in a very real sense, JWST's to-do list. For decades, exoplanet science was defined by discovery. How many can we find? How far can we see? The catalog grew faster than anyone expected, but the Cornell study represents something different, a turning point. The SETI Institute described it precisely, a shift from open-ended discovery to structured search, from chance to strategy. We are no longer asking whether there are planets. We are asking which ones we examine, in what order, with what instruments, looking for what. That is a different science, a more focused science, a science that is closing in. In the next episode, we ask what happens when JWST finds something it cannot explain, an atmosphere that should not exist. That episode is on the channel now. Somewhere in the Milky Way, there are 45 worlds where the temperatures allow water to flow, where rocky surfaces could shelter chemistry, where an atmosphere could breathe. We do not know if any of them are alive. We may not know for 10 years. We may not know for 50. But we know which ones to ask. And in science, knowing which question to ask and having the instrument to ask it is almost everything. The universe has been patient with us. Now, at last, we are becoming patient enough to listen. Next, on Quest for Alien Life, the universe is expanding faster than our models say it should, and nobody can explain why. That is next. Subscribe so you are there when it drops.